Hello friends, welcome to Risingpearl.com. Today we are talking about series 12 where we are learning about areas related to circles. Now this is webisode number 10 and today we are going to focus on solving questions on areas of combination of plane figures. Now we are calling this part 2 because in webisode 9, last webisode, we started taking a look at these type of questions. So friends, let's take a look at some more questions that fall in this category. Now, like we did in the last webisode, our strategy, we have to have a strategy of how we approach such questions. So the first part is that we have to try and see if we can find out which simple figures, by simple figures I mean triangles, circles, sectors of a circle, segments, squares, rectangles, regular polygons, etc. Which simple figures make up our given complex figure or shape. That means whenever you have these questions, first thing that should come to your mind is that what simple figures, which all simple figures make up this complex object. You're trying to break it down into simple figures. By simple figures we are referring to triangles, circles, sectors, squares, rectangles, regular polygons, so on and so forth. That is the area, that is figures whose areas we know. There is a formula for those areas and we can actually find out those areas. What is the second step? The second step of our strategy is that we need to find out which areas now need to be added or subtracted to get the required area. So in the question is always asking us to find the area of a particular part of the of the given shape, or whatever the case may be. We need to figure out, once we have broken down the shape into smaller, simpler shapes, now we need to find out, in order to get which area we need to find, which all areas we need to add and which all we need to subtract. And the third and final step in our strategy is simply to find out the areas of those individual simpler figures and then calculate the required area. So friends, we have looked at some questions for this in our last webisode. I hope you're following us along at risingpearl.com. If you have not got a chance, I'm going to provide the video link below for your quick reference. That's it. Let's take a look at some of these questions now. So the first question goes like, find the area of the shaded region in figure below if AC is 24 centimeters, BC is 7 centimeters, and O is the center of the circle. So we have a circle and there is a straight line AB. There is a line AC such that AC is 24 centimeter and BC is 7 centimeter. So these two lengths are given. So this is 24 centimeter and this is 7 centimeter. Now and O is the center of the circle, and we have to find out the area of the highlighted part, which is highlighted in blue. So how can we actually go about it? The first step is that, so what all simpler shapes are involved? Clearly we have a circle and we have a triangle. These are two shapes involved in this question. There is no rectangle, there is no polygon, or there is no other shape. Simply a circle and a triangle. Now the next step is, in order to get the area of the highlighted part, how can we get that? Which areas do we add, which areas do we subtract? How can we get this area? So one way to go about this could be that if we take the area of half the circle, which is this, so we can say that the required area could be, if you want to get half of the circle, area for half of the circle, and then if we can subtract out the area of the triangle, right? So let's think through this. So if we subtract the area of the triangle from the area of half the circle, then we will get a required area, right? So this is one way. What is the second way? The second way could have been if you were to join, let's say, OC. If you join OC, now you have two segments, segment AC, right? This is a segment, and you have a segment BC. So you can add simply the two segments and you can find out the area, which will be exactly the same. So the question is, so there are two or more approaches. There could be more approaches that you can use. So which one should we use? Now if you were to go with the segment direction, then we really would need to have this angle. and this angle. Now in the question there is nothing given that can really give us any clue about any of these angles. Now because AB is a straight line, right, so now this angle total is 180 degrees. So if we know one of them, we can find the other. But how do we really know the measure of this angle or this angle? It is not given and we cannot really find out. So we will try and go with the first route, which is that we will try to find the area of half the circle and subtract out the area of the triangle. Now, but this is also not easy, because in order to find the area of a circle, we need to really get the radius. Then we can find out the area of the circle. And secondly, so for AC, for area of the triangle, we know AC is 24, BC is 7. We have to find out this, which is R plus R. If we can find out R, then we can find out through Heron's formula because three sides will be given, and then we can find out the area from applying Heron's formula. Or if there is any way that we can find out area of a triangle using half base times altitude formula. So now let's see, let's start with what we know. So let's clean this up. So here we note that AB is a diameter of the circle with center O. Now remember, we know that angle in a semicircle is 90 degree. Any angle inside a semicircle is 90 degree. Now this is something, friends, this is a theorem that we have learnt in our earlier grade. So I'm going to provide that video link below for your quick reference. Note that AB is the diameter. So any angle, basically any angle which is made between the chord AB and any other point on the circle will be a 90 degree angle. So this angle must be 90 degrees. So now if this is a 90 degree, therefore triangle ABC or ACB is a right triangle. Now quite simply, if this is indeed a right triangle, what we have is, applying Pythagoras Theorem, we can find out AB square, because we know this is 24 and this is 7. So AB square will be equal to AC square, which is 24 square, plus BC square, which is 7 square. Now let's find out the 24 square over here. 24 times 24. So 4 4s are 16, 1 4 2s are 8, 1 9, 2 4s are 8, and 2 2s are 4. So this basically comes to 6 8 9 8 17, 1 5 76. So this is 576 and this is 49. So then this together, if you add these two, it will come to 5 2 6. Or this value, or AB square is 625. Now, or AB should be equal to square root of 625, which will be actually 25. So AB is 25. That means this value is 25 by 2 and 25 by 2. Because AB, which is the diameter, that is 25. So each length is half of the diameter. So our radius, in other words, the radius is equal to 25 by 2. So now that we have found out the radius, let's give ourselves a little bit more space here. So now that we know our radius, right? And also, so we can, since we know our radius, so we can say now area of the circle, whole circle. So area of the circle is equal to pi r square. R is 25 by 2. Pi r square. This is the area of the circle. So we can say that area of semicircle, because we need to really have the area of the semicircle highlighted in blue here. So area of the semicircle will be half of whatever this area is. So this times pi r square, where r is 25 by 2 whole square, and yeah, that's it, pi r square. So this times half times this. So if you were to simplify this, and we will keep it still in the pi form, so we will see that it will be 25 square times pi divided by 2. Now this 2 will become 2 2s are 4 times 2 is 8. So this area of the semicircle is 25 square pi divided by 8. This much centimeter square. That is the area of the semicircle. Now let's go ahead and find out what can we tell about the area of the triangle. Now area of the triangle, because an angle inside a semicircle is 90 degrees, so what we notice is that this length is 24 and this length is 7. So because this is perpendicular to BC, so this is actually the height or the altitude, and BC is the base. So very simply we can say area for our triangle ABC is equal to half times AC, which is the height or altitude, times the base, which is BC. Or we can say area of this triangle is half times AC is given as 24 times 7, or 2 12s are 24 and 12 7s are 84, or this area is 84 centimeter square. Now I actually used the half base or height, half base times height to find the area, because that is the most simplest. I could have actually found the same value using Heron's formula as well to find the area. So what we have done, friends, is that because the length AB is 25, which we have found out using the Pythagoras theorem. Now, so we have found out both the areas. So quite simply at this point, we can basically say, so the required area, right? So our required area is equal to, like we have seen, this is equal to this minus this. So simply whatever the value that you have here, which is 25. Now at this point you have to open this up and perform the actual computation. This minus what was the value that we had seen over here, this was 84. So this times this minus 84. So whatever this value is, this centimeter square is the answer. Let's take one more question. So wow, this is like some funky looking thing. Let's read the question. In a circular table cover of radius 32 centimeter. So we have a circular table cover. So this looks like a circular table cover of 32 centimeter. That means if this is a center and we can join any point on the circle, any point. So this is the radius and that is given as 32 centimeter. A design is formed leaving an equilateral triangle ABC in the middle. So we have a round circular table cover, but then we take out an equilateral triangle. We know equilateral triangle, all these angles are equal and they will be all 60 degrees. So we cut out, because formed by leaving, so we cut out an equilateral triangle ABC. So let's name this ABC. Alright. In the middle as shown in the figure. Find the area of the design, which is the shaded part. So how are we going to solve this, friends? So first thing is that first step, we have a circle and a triangle. These are two shapes we are dealing with. The second step is clearly we have to find out the area of the circle, right? We have to find out the area of the circle and then subtract the area of the triangle. So what we have to do, we have to find out the area of the circle and then subtract the area of the triangle to find out what is highlighted, that is the design, right? Now, in order for us to find out the area of the circle, and this is just the design, these printed stuff, They look like some fancy farm animal kind of a thing, but this is just the design, so we are going to ignore it for all practical purposes as far as solving the question is concerned. So now to find out the area, we need to know the radius. That's the only thing we need to know here. And now to find out the area of an equilateral triangle, now this is the equilateral triangle. Now recall that equilateral triangle's area, so each of these are 60 degrees. To find out the equilateral triangle, I think the formula, so this formula is really pi r square minus, if I recall correctly, this formula is 3 by 4 times a square, where a is the length of one of the sides. Because all sides are equal in length, so a is one of the sides, then the area of an equilateral triangle is given by root 3 by 4 a square. So we find out our radius, so our required area is equal to pi r square, where r is the radius of the circle, minus root 3 by 4 a square. Now r is given to us 32. So this value we will be able to find out. It is this length a that we need to be thinking about. How do we get to a? A is nothing but the length of this chord. So AB or BC or AC, they are all the same, and each of them is a. So now that, friends, we understand how and what we need to do, let's find out how do we actually go ahead and get this thing done. So first thing is that, so for our now let's focus on the equilateral triangle, because pi r square quite straightforward and that will be done. So in the equilateral triangle, what we do, friends, is that let us draw now each of these, so let's draw a perpendicular. From here, let's draw a perpendicular and then join this vertex. Let's name this first ABC. This is ABC, and now this is the radius which is given to us, right? And now we join this, we drop a perpendicular. So now if you look at this triangle, now if we were to join this, and let's say also join these two, we have seen earlier how we can prove. Let's name this, so this is center O, and let's call this point as D. Now we have seen earlier quite a few times how triangle OBD, we can prove that this triangle is congruent to triangle OCD, right? Because this is 90 degrees, this is 90 degrees, this is R, and the side OD is common. So by RHS congruence rule, these two triangles are congruent. These two triangles are congruent. So this angle should be equal to this angle, right? The other thing is that, so now similarly this angle should be equal to this angle. So now because we have an equilateral triangle, each of these sides, right? So what is the angle that each of the sides will be making at the center? Meaning what will be AOB, BOC and COA? Because these sides are equal, so they will be subtending equal angles at the center, right? So each of these angles will be 180 divided by 3, or each of the angles, that is angle AOB will be equal to angle BOC, which will be equal to angle COA, and each one of them will be 360, which is the total for a circle, divided by 3, or now that should be 120. If each of them is 120, then half of it is 60. So this is 60 and this is 60. So now if you look at, let's see if we can give ourselves a little bit more space over here. So now what we have is, let's just focus on this triangle. So if you just focus on this triangle, which is OB, so remember this was our ABC, and this point is D. If you just focus on in triangle OBD, this angle is 60 and this is 90. So, and we know the radius. So if we do cos 60, applying the trigonometric ratio, cos 60 degree, because this angle is 60, cos 60 is adjacent side, which is OD, divided by the hypotenuse, which is R, and R's value is 32. Now we know cos 60 is equal to 1 by 2. So from here we can say OD, the value of OD is equal to 32 by 2, because 32 will go over there, or 16. So OD, this length is 16, right? Similarly, we can find out what is the length of BD. BD will be sine 60. So sine 60 degrees is going to be, so this is 60, sine 60 is opposite side, which is BD, divided by R, which is 32. Now sine 60 is actually square root 3 by 2. Or from here we find out that BD is actually equal to, this goes over there, so it is 32 times square root 3 by 2, and 32 and 2 will cancel out, so it will be 16 square root 3. Now we just saw that these two triangles are actually congruent. So D is a midpoint, so BC should be equal to 2 times BD, create some separation here. So BC is equal to 2 times BD, or equal to, BD is this, so that will be, if this multiplied by 2 will be 32 square root 3. So now each of these sides, because this is an equilateral triangle, each side is 32 square root 3. So A, which is the sides, each side, that A will be equal to 32 square root 3. So friends, now what we have is that, now I think finally we can say that we have our desired, let's see, we actually needed to have this, right? So our desired area, so this is 32, R equals 32. So this area is pi 32 square. And here what we have found out is, if each of the side is A, because this is an equilateral triangle, 60, 60, 60, so area of equilateral triangle is square root 3 by 4 times A square. So then this becomes square root 3 by 4 times A square. A is 32 square root 3 whole square. So then our desired area will be equal to, we just simply need to solve this. So what you are going to do, what you want to do is this minus this. So from here, if you open up the square, what you will get, you will take 32 square common, right? You want to take 32 square common, and then here you will have 22 by 7 minus, so this will, if you open up, it will become 32 square, so that is something you're taking common, and then 3 square, root 3 times root 3 will be 3, so you will have 3 times root 3, so you will have basically 3 square root 3 divided by 4. So if you simplify this, then you will find out the value of what is the area of the design. So which is basically equal to area of the circle minus the area of the equilateral triangle. So friends, this is how you solve these questions that involve more than one simple figures. So applying the strategy one by one, step by step, we find out how to solve such questions.